Could you at any point envision that the finish of our universe might be the beginning of the next one? Maybe even one that is completely different from our own? Speculations about the multiverse are nothing new in the universe of astronomy, but evidence for this hypothesis is emerging. The James Webb Space Telescope has recently delivered the first image of another universe. Since the earliest days of recorded history, people have looked up at the stars and contemplated the sun, the moon, and the stars. For the primary people, the sun and the moon were openings in the sky through which light came into a world that these individuals imagined as a disk. Over centuries, our species has found that we live on a ball that rotates and revolves around a star, which is also a sphere. Along with millions of other stars and planets, we are a small part of an enormous world and an even bigger universe. Despite the fact that we have had powerful telescopes for around 100 years, we still don't know everything about space. Scientists are continually discovering more phenomena in the universe. They find answers to old questions, yet many mysteries remain inexplicable to this day. We still don't know who made the universe or why. Until recently, we didn't know whether the universe has an end or is unending. With our best telescopes, we have so far been able to see around 13.3 billion light-years away. When we look, we are continuously looking back in time because the light that telescopes like Hubble capture has traveled through space-time to reach us. We see the image of the moment when the light began its journey to us. This glimpse into the past is fascinating. In this manner, researchers have been able to look back almost to the birth of the universe, or at least that's what they thought for quite a while. Then along came James Webb, the new space telescope from NASA, the Canadian Space Agency, and the European Space Agency (ESA), which began operation in the summer of 2022. Even the first images from the telescope provided explosive material that still sparks heated discussions among researchers today. To be exact, there are 6 galaxies that should have existed at the dawn of history, for which there is no logical explanation. Galaxies like Glass Z13 previously existed 250 to 350 million years after the Big Bang, and that is theoretically impossible. At this moment, there should have only been a few stars slowly coming together to form entire galaxies, and several billion years would have been necessary. What does this mean? Is the theory of the Big Bang wrong, or is there a completely different explanation? Indeed, there is one. We might be looking at another universe here. The image of the galaxy cluster max J0647 plus 715 reveals a stunning view of a group of galaxies like precious gems shining in the infinity of space. What truly excites researchers about this image isn't just its beauty, but the facts. The same region of the universe was already imaged 10 years ago by the Hubble Space Telescope. However, the quality of the image wasn't quite as informative, and particularly, the old and reddish objects in the background couldn't be decoded. It was only clear that they existed, and that was peculiar enough. The gravitational lensing effect, where small and distant objects in the background are magnified by objects in front, told scientists that these blurred points of light were old, very old indeed. James Webb then revealed stunning new details thanks to the triple lensing effect. Galaxies so old, so bright, and so highly organized that our Milky Way seems rather ordinary in comparison. Today, researchers are especially puzzled by the data on brightness intensity. If the interpretations are correct, these galaxies have produced 10 times more stars than our galaxy. All the rules of astronomy fail at this point. It's as if scientists have built all cosmological views around an assumption that now clearly turns out to be false. This is a shock for those who believed in the existence of a single universe and assumed that everything within this universe could be explained with the equations of Einstein's theory of relativity. Meanwhile, other branches of physics have long hypothesized that it's much more likely for us to live in a universe that is just one of many, with many extra dimensions or universes that could exist alongside or even within our own reality. These universes could contradict our physical concepts since they belong to a completely different universe and exist within a completely different time structure. One of the first discovered galaxies was Glass Z12. Galaxies are usually named after the research systems through which they are found. GLASS stands for Grism Lens Amplified Survey from Space, and Z12 indicates the value of the redshift. Each research group uses slightly different designations, and giving the redshift value of a discovered universe is not mandatory. Universes can also get simple numerical designations. To laypeople, Z12 may sound unremarkable, but astronomers hold their breath with this designation. This value means the world already existed 300 to 400 million years after the Big Bang. Therefore, it's very old and, according to current cosmological theories, seemingly impossible. The key discovery of glass Z12 was already celebrated as a sensation in the academic community, but much more ancient and peculiar galaxies followed. The world candidate CR793316 seems to top all the anomalies. This object is so old that it already existed 250 million years after the Big Bang. However, this object displays another oddity. Measurements of redshift yielded two very surprising results. In one instance, the object showed a redshift of 16.7 Z, indicating extreme age. Then measurements of objects near CR793316 were taken, and based on those, the galaxy exhibited a completely different redshift. The world appeared as if it existed in two places and two times simultaneously. Scientists jokingly refer to this world as Schrödinger's world, inspired by the famous quantum physicist Erwin Schrödinger, who demonstrated that at the quantum level, two or more realities can exist simultaneously. According to these theories, it's not just ordinary to have two universes, but there are infinitely many with infinite variations. Scientists attempting to wrestle with these measurement results and known perspectives would still like to believe in a measurement error or even question whether these points of light are universes at all. While the spectroscopy examination to confirm the redshift is still ongoing, further data analysis from James Webb's NIRCam system has already definitively ruled out the possibility of it being a low-mass star or an unimpeded active galactic nucleus. We must suppose that the discovery of CR793316 was only the beginning of what is possible. NASA has suggested that the James Webb Space Telescope could theoretically detect galaxies with a redshift greater than 20. These universes would have existed only 200 million years after the Big Bang, or perhaps the telescope is looking even further into dimensions of our universe, which might confirm that we have encountered a boundary of reality unrelated to the Big Bang at all. At this moment in time, we can no longer talk about the dawn of mankind, the universe, or the time after the Big Bang. Rather, we change the terminology and refer to it as the edge of the observable universe. There lies another intriguing source of light that shows a very high redshift value in our images. To prove that a 2744 Y1 is indeed a galaxy whose light has traveled more than 13 billion years to reach us, a group of scientists has combined the best telescopes in the world. The Spitzer, Tundra, and Hubble telescopes have captured another image of this remarkable galaxy by gathering data from different frequencies of light and combining them into one image. Not only is the age and distance of this galaxy fascinating, but the rate of star formation surpasses anything previously considered possible in physics. Despite being 10 times smaller than our own Milky Way, Galaxy AL 2744 Y1 produces stars at a rate that is 10 times faster than that of the Milky Way, which is unusual for a galaxy in a young universe. The observable universe currently has a radius of 46.1 billion light-years. Beyond that, there is possibly much more. The better our telescopes become, the further and more detailed our observations can reach. James Webb is theoretically capable of looking back 13.6 billion years. If the Big Bang occurred 13.8 billion years ago, there would eventually be a limit to our observations. This is because a few hundred years after the Big Bang, the universe would have been completely dark. The first stars are believed to have formed only after 380,000 years. If researchers continue to find even older galaxies, it will convincingly prove that all previous cosmological assumptions were wrong. As of now, scientists at NASA are gaining initial experiences with the new telescope, which have already been astonishing. However, we know that time always brings new experiences, and in a few years, scientists might be able to extract even more from the telescope's capabilities. Then, perhaps, we could finally see what truly happened at the supposed beginning of time. Although the theory of the Big Bang seemed plausible for a long time, there was no evidence to support its accuracy. With the rise of quantum physics, it became even more likely that our universe is an incredibly variable, diverse, and possibly complex place. Models of the bubble universe or pocket universe suggest that our universe is encased in a giant bubble and shares space with many other bubbles of various sizes. The pocket universe assumes that within a universe, there are different segments where similar but also different physical states may prevail. Through these pockets, we could access other dimensions or corners of the universe where different laws apply. In fact, there are almost as many pieces of evidence and hints for these theories as there are for the Big Bang theory. The assumption of the Big Bang and the principles of Einstein's physics were established long before the theories of quantum physics existed. Despite the fact that physicists have known for a long time that we need a new way of thinking in order to make progress in knowledge, there is still a gap between these branches of physics. The James Webb Space Telescope could now bridge that gap.